All right, so today we're starting polynomial functions. This is the algebranation notes, which calls it section 6, but we call it module 5 because that's what the county calls it. So everything that you find in Schoology will be under module 5, even though these notes say section 6. I know that's confusing, but we don't have it set up the same. So for those of you at home, I started this lesson and forgot to push record, so I'm just going to go back through this real quick to catch you up. This is it from the algebranation workbook. It starts on page 133. If you're at home, I have downloaded the whole workbook on Schoology. You can download it there and print it off if you don't have your own copy, if you weren't here when we passed them out, okay? All right, so a polynomial is a finite sum of monomials, and finite is like the opposite of infinite. So infinite means there's no ending, it goes on and on. Finite means it stops at some point. So you just cannot have unlimited monomials. They can't go on forever. You have a certain set number. Well, it's important to know what a monomial is. Okay, you need to know what a monomial is for the whole rest of this section. And I'm going to say this fast because I've already written it, but if you're at home, you probably need to pause the video so you can copy it down. You're going to need this definition. So a monomial can be just a number all by itself. The number 5 is a monomial. The number 12 is a monomial. It can be just a variable all by itself. So x is a monomial, k is a monomial, m is a monomial. Or it can be the product of a number and variable. Remember, product means the result when you multiply. So like 2x is a monomial. 3x squared is a monomial. 3a squared, b squared, c squared is a monomial. Okay? So a polynomial is separated. It's a whole bunch of monomials. Or it can just be one monomial. I know it's kind of confusing. But the monomials are separated by positives and negatives. That's how you know when you have more than one. But you have to be very careful because your variable's got certain restrictions that you have to pay attention to. So a variable cannot have negative exponents. If it does, then it's not considered a monomial, okay? You're going to see variables with negative exponents, but when you do, we don't call them monomials or polynomials. Variables cannot be in the denominator in order to be a monomial. And exponents of variables must be positive integers to be considered a monomial. If you have a negative integer, it's not a monomial. Or if the number is not an integer, it's not a monomial. Do y'all remember what integers are? Kat, you remember? Anybody remember? Okay, so integers are basically counting numbers, 0, and their opposites. Do y'all know what I mean by counting numbers? If I said, start counting, where would you start at? You'd say 1, 2, 3, 4, 5, 6, 7, 8. You wouldn't say 1, 1.2, 1.8. You wouldn't include decimals and fractions, right? So integers are the counting numbers, also 0, and the opposite of the counting number. So like -1, -2, -3, -4. So in simplest form, if you don't have a fraction or a decimal, once it's reduced, those are integers, okay? So the directions want us to look at each of these examples and state if it's a polynomial can be a monomial or a sum of monomials. You can add them or subtract them, that doesn't matter, okay? So let's look at the first one. 3x squared plus 2y plus 4. Do you think that is a polynomial? Let's look at your first. Is this a monomial, 3x squared? Yeah. Is 2y a monomial? Yes. Is 4 a monomial? Yeah. So a polynomial is the sum of monomials, okay? Is there anything there that we would say no, it's not? No. So yes, it is. Look at the next one, 8a raised to the 1/2 plus 2c. Is that a polynomial? Look at 8a to the 1/2. Is that a polynomial? What's wrong? The 1/2, right? Now, the number itself, it can have an exponent that's a fraction. That's okay. The variable cannot, okay? So this is not a polynomial. And the directions also said change the expression so that it is a polynomial. In your homework, it doesn't ask you to change it. It asks you to put a box around the problem. So our problem here, which is not asking us to do this, it's just in your homework, is the 1/2, okay? So they just want us to change the expression and make it a polynomial. They're not asking to make an equivalent expression. They just say, okay, just replace that with something that's going to make it a polynomial. So could we say like 8a squared plus 2c, or 8a cubed, or just 8a, anything. But you cannot have that 1/2 as the exponent of the variable. Now, be careful. These, what I just rewrote, these are not equivalent. I'm not saying that 8a to the 1/2 is the same thing as 8a squared. It's not the same. Does that make sense? They just wanted me to replace it with something that would make it a polynomial. Look at the next one, 5r plus s divided by t. Is 5r a monomial? Yes. Is s divided by t a monomial? A monomial can be a variable by itself, a number by itself, or the product of a number and a variable. You also cannot have a variable in the denominator of a fraction. No, it's not, okay? First of all, you can't have the sum of the quotient of two variables, and you can't have a variable in the denominator. So this is the problem here. So we're going to say, no, it's not a polynomial. And we could change that to 5r plus, if we said st, is that okay? Product of two variables, that's fine. Again, they are not equivalent. (5a plus 4b quantity divided by 2). Now remember, that's the same thing as 5a being divided by 2 and 4b being divided by 2, which of course we could simplify to 4b divided by 2. Is there anything there that makes this not a polynomial? No, just because you see a fraction, a lot of kids say, well, there's a fraction and there was a fraction in the last one and it wasn't. So yeah, it wasn't because there was a variable in the denominator, okay? You can't have a variable in the denominator. Here we have fractions, but the denominators are numbers, that's totally fine. Our variables, they don't have any weird exponents that we have to worry about. So yes, this is a polynomial. So just to be clear, 5a squared is a monomial, plus 4b divided by 2 is a monomial. Polynomials is like the umbrella statement, okay? A monomial is a type of polynomial. How about the next one? Is that a polynomial? It's not. What's the problem? Exactly. It says over here your exponents cannot be negative of a variable. Of the number, that's fine, but not of a variable. Is 2y, is that considered a monomial? Is anything wrong with that? No. How about 7x cubed? Is anything wrong with that? No. So the only thing we need to fix there is the -3. So could we just make it +3? Yeah. So 9x cubed plus 2y plus 7x cubed. I forgot to say no. Again, these are not equivalent. I'm not trying to say that 9x raised to the -3 is the same thing as 9x cubed. They're not. And I should have written that up there so I didn't think that they were. Julio? Yes. If it's an emergency, if not, I'd rather you wait. Okay, on the right side of your page, we're going to classify polynomials. We can classify them based on how many terms they have and also based on how many degrees that they have. Now on your homework, I noticed the students who had this lesson yesterday, in the charts that they had to figure out, they didn't always read the directions. Okay, so it's important when you fill out your charts, are they wanting us to name it based on terms or degrees? And this first one says, we can classify polynomials based on the number of, that says terms. If yours has a hole through it, you might want to rewrite it like mine does, terms. So your terms, your monomials, are separated with pluses and minus signs, okay? So on that first one, it tells us it has one term. 3x to the 7th. A lot of kids think that's two terms because they're like, well, 3 is a term and x to the 7th is a term. It's not. It's just one. If it's a product of a number or a number and variables, it's just one term. You don't see it being separated by pluses and minuses, right? So that's one term. So what do we call that? We've said the word several times on the left side of the page. Monomial. Then we have two terms, 5m plus 6n. 5m is a term, 6n is a term. Any idea what we call that? Binomial. Three terms. 8r squared is a term, 4s is a term, 7t is a term. What do you think we call that? Trinomial. We've said all of these words this year. We just have not written them ever in our notes. Then we have four terms. A is a term, 2b is a term, c squared is a term, 4 is a term. What do you think we call that? What? Seems like it would be like quadrinomial or something, but it's not. It's called a polynomial with four terms. Only 1, 2, and 3 terms have a special name. Anything greater than that, you just say polynomial with 4 terms, polynomial with 5 terms, polynomial with 6 terms. Only the first 3 have a special name. Now on your homework, it's going to ask you to name the polynomial based on how many terms it has. And sometimes they are not simplified. So like maybe there's parentheses that you have to get rid of or like terms that you have to combine. If it's not simplified, like on all of these, there was no parentheses, there was no like terms to combine. So they were already simplified. But if it's not, you simplify it first and then you determine how many terms it has, okay? So simplify before classify. And I didn't really point that out to my first period yesterday, or fourth period, because I didn't realize on the homework that it did that. I wish sometimes on the notes it doesn't do everything that does on the homework. So a lot of those students got it incorrect because they didn't simplify first. So make sure you do that. I'll do an example at the bottom so you can see what I'm talking about. All right, on the next table, they want us to classify polynomials based on how many degrees it has. We've talked about degrees before this year, well, technically last year. Do y'all remember what a degree means? It's kind of like an exponent, but a little different. Then we need to write it down. Degree is the exponent of the variable. Degree is the exponent of the variable. So the first one is, it says it has 0 degrees. An example is a number 3. Well, doesn't 3 have an exponent of 1? So why is it saying it has 0 degrees? Yes, because there's no variable, right? Numbers, yeah, 3 has an exponent of 1, but it has 0 degrees because it doesn't have a variable there. So a number by itself is always 0 degrees, and we call that a constant. The next example, it says it has 1 degree. So look at 2x. How many degrees does 2x have? 1, because you have x has an exponent of 1. So that's 1 degree. We don't care about how many exponents 2 has. Your degrees are only variables. How many degrees does 3z have? 1. So when you decide how many degrees an expression has, you take the highest degree. Well, since they're both the same, we just say it has one degree, okay? So that is called linear. 1 degree is linear. That's what we spent pretty much all of Algebra 1 doing. The next example, how many degrees does 3x squared have? 2. How about 2y squared? 2, so the highest degree is 2. This is what we worked on all before break. What were those called? Those parabolas. Start with a Q. Quadratic. Next example, how many degrees does 6y cubed have? 3. Do you know what we call that? It's called a cubic polynomial. So look at the next one, 5a to the 4th plus 3b cubed. How many degrees does 5a to the 4th have? 4. How many degrees does 3b cubed have? 3. We name a polynomial based on the highest degree. So we're going to name it based on how many degrees? 4. And we call that quartic. And there's more, like 5 degrees is quintic. 6 degrees, I don't remember what 6 degrees is, but we only have to know up to 4 degrees. So let's also make a note. Name a polynomial based on the highest degree. So you can name a polynomial based on both things, the number of terms and the number of degrees, okay? I think on your homework, it's one chart is all about degrees and one chart is all about number of terms, like it is in the notes, but I just want to show you. And I want to show you how you need to simplify before you make any determinations, okay? So let's say if I had x squared minus 3, open parentheses, x minus 2, close parentheses, plus x squared. And I want you to name it based on degrees and number of terms. Well, a lot of students go, well, this is a term 1, 2, 3, 4, that's 5 terms, and it has 2 degrees. Well, simplify before you classify. Okay, can we simplify this? I mean, we've got parentheses, right? So can't we distribute to get rid of those? So we would have x squared, distribute the negative 3, so negative 3x plus 6 plus x squared. Do I have any like terms? Yeah, what's x squared plus x squared? 2x squared. Does negative 3x have a like term? No, and 6 doesn't have a like term. You know how all year I've said, write it in standard form. It depends. You start with the highest degree down to the lowest degree. 2 degrees, 1 degree, 0 degrees. We talked about that a bunch, right? So now, how many degrees does this have? 2. And what do we call a polynomial of 2 degrees? Quadratic. How many terms does it have? 3. What do we call a polynomial of 3 degrees? So we would call this a quadratic trinomial if we were naming it based on both the number of terms and the degrees. So if it can be simplified, you do that first and then you name it. So we would have gotten the quadratic part right, but we wouldn't have got a polynomial with 5 terms correct. Yes. 2. This has 2 degrees, 1 degree, 0 degrees. When you're naming it, you look at name a polynomial based on the highest degree. So since the highest degree was 2, that's a quadratic. Okay. How about this one? 2x cubed minus 7. Is there anything to simplify? No. How many degrees does it have? 3. How many terms does it have? 2. So we would call it a cubic binomial. I meant to say, let's see, negative 2x squared minus 5 plus 2x squared. I know that's messy. Sure. Can I simplify anything? What? Negative 2x squared and positive 2x squared. Don't they cancel? And leave me with what? Negative 5. How many degrees does -5 have? None. And how many terms is it? It's a constant monomial. No degrees because there's no variable and it's only one term, so that's monomial. So constant monomial. Like I said, on your assignment, it's not going to have you give both names at once. One chart will be all about degrees and one chart will be all about the number of terms. Okay? Y'all cool with that? So all of these things are called polynomials. That's the broad term. And then we can classify it more specifically based on the number of degrees and the number of terms. Okay? All right, next page. Page 134. Describe two polynomial functions that we have seen so far. Well, what did you spend all of Algebra 1 doing pretty much? What kind of functions? Linear. An example of a linear function would be like y equals 2x plus 1. And what kind of shape does a linear function make when you graph it? It's a line. And I drew a line with a positive slope because the example that I gave had a positive slope, right? What other kind of function have we worked on? This year specifically right before break. Quadratic. So quadratic has a highest degree of 2. So let's say like y equals 2x squared plus 1 would be a quadratic. Or we could have 2x squared plus 3x plus 1, right? As long as your highest degree is 2, then that's called a quadratic. And what kind of shape does a quadratic make? It's a parabola. Would this one that I gave an example of open up or down? Up. Y'all remember what its y-intercept would be if we were like actually graphing it? Be 1, right? It's whatever the constant is. Constant's the number with no degrees. Explain if exponential functions are polynomial functions or not. Well, an exponential function is a function that has a variable as an exponent. So this is an example of an exponential function. You worked on them some in Algebra 1 and I believe in geometry. We haven't really worked on them much this year, but we will be working on them. Okay? So this is a function, but is it considered a polynomial function? Why? Exactly. Your exponents for polynomials have to be positive integers only, right? A variable has to be a positive integer. Exponent has to be a positive integer. This is not. So this is not a polynomial. Because the exponent cannot be a variable. Bless you. All right, try it. Select the word that correctly completes each of the following statements. A monomial is always, sometimes, or never a polynomial. What do you think? Damon? Damon? What do you think? Need you awake, please. Always. A monomial is always a polynomial. Remember, polynomial is the broad term. If it's considered a monomial, it will always be a polynomial. A polynomial is always, sometimes, or never a monomial. True or false? Or which one? Sometimes. A polynomial can be a monomial, a binomial, a trinomial, a polynomial of 4 terms, polynomial of 5 terms, right? So yeah, sometimes it's a monomial, sometimes it's not. A quadratic function is always, sometimes, or never a polynomial function. Always. Quadratics are always polynomials. Polynomial can be linear, quadratic, constant, cubic, quartet, quintet. So if it's quadratic, it's always a polynomial. Coolio? So the title of this lesson was called Classifying Polynomials and the Closure Property. Well, we've spent the first half of this classifying polynomials, okay? Do we know how to classify polynomials based on the number of terms and degrees? Do we know how to determine if an expression is a polynomial or not? Okay, great. Now we're going to work on the closure property, which you've seen the closure property before. We haven't really worked with it much this year. All right, and if you pay attention, it's really not a big deal. Okay, a set is said to be closed under a specific mathematical operation if the result that occurs when you perform the operation on any set, on any two members of the set, is also a member of the set. What does that mean? Now, it sounds confusing, but it's not really. So determine whether each of the following statements are true or false. If a statement is false, write a counterexample. So my first example says integers are closed under addition. I know y'all don't like writing and you like to write as little as possible, but I'm going to rewrite this in words that kind of make more sense to us, and you need to do the same so that when you go back and look at your notes, you're like, what does that mean? Integers are closed under addition. I read the definition and I have no idea what that means, okay? What it's saying is, if I add two integers, add because it's addition, integers because that's what we're talking about. If I add two integers, then the result is an integer. That's what closed means. If I add two integers, the result's an integer. And we talked about what integers are, right? Counting numbers, 0, and their opposites. Do you think this is true or false? If I add any two integers together, I'm always going to get an integer. You think it's true? If I can prove it false with just one example, then it's false. Give me two integers. So 3 plus 7 is 10. 3 is an integer, 7 is an integer, 10 is an integer. Okay? Give me two more. 5 and 6. 5 plus 6 is 11. All integers. What if I did like 0 minus 9? 0 is an integer. Negative 9 is an integer. What do you get? Negative 9. Is negative 9 an integer? Are you ever going to add two integers together and the result be a decimal or a fraction? No, if you start with two integers, you're going to get two integers, right? So we would say this is true. If you can come up with just one example that makes it false, then it would not be considered closed. So if what you start with and what the result is are the same, then that's called, then we say it's closed. If it's not the same, then we don't say it's not closed, okay? Odd numbers are closed under addition. So what that means is if I, and it's talking about addition, so add, if I add two odd numbers, then the result will be an odd number. Why do you say it's false? Okay, 3 is odd, plus, because it's addition, plus 7 is odd, and the result is 10, that is even, right? So you are correct. We would say this is false. Odd numbers are not closed under addition. Even numbers are closed under addition. That means if I add two even numbers, then the result is an even number. You think that's true or false? True. Let's think of some examples. 2 is even plus 4 is even equals 6 is even. How about -8 plus 2 is -6, even, right? It's divisible by 2, it's even. 12 plus 8 is 20. Just coming up with random even numbers and adding them together. Can you think of any even number that if you add an even number, the result won't be even? No, it's always going to be the case. So since we cannot come up with any counter examples, that one would be true. Negative numbers are closed under multiplication. So now we're talking about multiplication. So this means if I multiply two negative numbers, then the result will be a negative number. True or false? False. Give me an example. -1 and -8. -1 times -8 is +8. Every single time you multiply two negative numbers together, you're always going to get a positive number, right? So this is definitely, negative numbers are not closed under multiplication. So they said it was closed, so that is false. Y'all understanding what the closure property means now? Odd numbers are closed under multiplication. That means if we're talking about multiply two odd numbers, the result is an odd number. Give me two odd numbers. 7 and 7 times 3 is 21. Everything's odd. Give me two more odd numbers. 5 times 9 is 45. All odd numbers. One times 7 is 7. All odd numbers. 5 times 3 is 15. All odd numbers. Anybody think of anything that would make a false statement? Or would make it false? No, every time you multiply two odd numbers together, you're always going to get an odd number. So this one would be true. Julia? All right, we're almost finished. We have one more page to go. So page 135. When referring to the closure property, what do you think polynomials form a system analogous to the integers means? They got all big worded on us, didn't they? Do we know what analogous means? You know what analogy means? Analogous means basically like it's similar to or it's like. So what they're saying is when you're talking about the closure property, basically the rules for polynomials are similar to the rules for integers. Like if it's closed for polynomials, then it's going to be closed for integers. That's what they're trying to say. So let's say this means when referring to the closure property, The rules are similar for integers and polynomials. So if something is closed for integers, it will be closed for polynomials. This means when referring to the closure property, the rules are similar for integers and polynomials. So if something is closed for integers, it will be closed for polynomials. So let's practice. Determine whether each of the following statements is true or false. If the statement is false, write a counterexample. Polynomials are closed under addition. That means if I add two polynomials together, the result is going to be a polynomial. You think that's true or false? Say I have 2x, is 2x a polynomial? And 2x squared. Is that a polynomial? If I add them together, I get 2x squared plus 2x. Is that a polynomial? Yes. Can you think of any instance where if I start with a polynomial and I add it to another polynomial, they're both polynomials, that the result is not going to be a polynomial? Like it's going to give me a negative exponent for the variable, or it's going to put a variable in the denominator. Is that going to happen when I add? No. So this is true. Polynomials are closed under addition. Polynomials are closed under subtraction. Do you think that's true or false? If I subtract two polynomials, if I subtract a polynomial from another polynomial, the result's going to be a polynomial. Or you think it's going to do something and give me a negative exponent for a variable, or a variable in the denominator if I subtract them. No, you just add like terms, right? It doesn't really change the exponents at all when you subtract polynomials. So this is true as well. So isn't that telling us that integers are also closed under addition and integers are also closed under subtraction, given what we just wrote at the top of the page? Okay. All right. Determine whether each of the following is true or false. We're going to do the same thing. Polynomials are closed under multiplication. Think that's true or false? If I multiply two polynomials together, you think I'm going to get a polynomial? Yes, you will. So same is true for integers. Polynomials are closed under division. True or false? So say I have 2x and 2x squared. If I did 2x squared divided by 2x, y'all know what that gives you? It gives you, remember, 2x squared means 2 times x times x. 2x means 2 times x. If I'm dividing, 2 divided by 2 is 1. X divided by x is 1. Aren't you just left with x in the numerator? Is that a polynomial? Yeah, you can just have a variable, right? But what if I had 2x divided by 2x squared? Doesn't that mean 2 times x in the numerator and 2 times x in the denominator? 2 divided by 2 is 1. X divided by x is 1. So that leaves me with a 1 in the numerator and an x in the denominator. Is that a polynomial? No. You can have variables in the denominator. It's just not considered a polynomial if you do. So I gave you one example that would make it true, but if I can come up with any examples that make it false, then it's not closed. So this is false. Polynomials are not closed under division. So are integers closed under division? No, because we said the rules for polynomials and integers are analogous, right? Y'all cool with that? So polynomials and integers are closed under addition, subtraction, multiplication. Neither are closed for division. Beat the test. Two functions are given below. So we have function f and function g. Candace solved function f divided by function g as follows. So she has function f divided by function g. So this means that each one of these terms is being divided by x squared. So she wrote that out on her next step. Nothing's incorrect there, everything's fine. Then she went and reduced. X cubed divided by x squared is x. Is x a monomial? Yeah. 2x squared divided by x squared is 2. Is 2 a monomial? Yes. Negative 3x divided by x squared is negative 3 divided by x. Is that a monomial? No. What's the problem? Got a variable in the denominator. 4 plus x squared reduces to 4 plus x squared. Is that a monomial? No. So can we consider this to be a polynomial? The whole thing is a polynomial? No. If even one term has something that's not a monomial, then it's not a polynomial. Candace's work illustrates that polynomials are closed or not closed under addition, division, multiplication, subtraction. Are we going to say closed or not closed? Not closed under what? Division. She was dividing there, and the result was not also a polynomial. Explain your answer. I'm going to say when Candace divided a polynomial by a polynomial, the result was not a polynomial. So that makes it not closed. Now for your assignment. And I do not want to see a phone out until this is completed and turned in. Okay, we're not shutting down now and being on our phone for the rest of the class. You're working on this. If you finish it, then you can get your phone out once you hand it in to me. And as you know, I'm grading this for accuracy. I'm going to keep this video going so I can explain it at home. So don't get this out yet. Let me explain it first because I want it in the video, okay? In the practice book, we're going to tear out one page. It's page 110. Don't do it yet. Don't do it yet. Just let me explain first. On page 109, the student learning plan, we don't do anything on that side, okay? Make sure your name's on it. On the first part, it wants you to determine whether each is a polynomial or not. And it says if it's not, just draw a box around the part that makes it not a polynomial. You don't have to rewrite a new one, so it's a little different than what we did in the notes. You just draw a box around it, 3 directions. Part 2, classify the polynomials by the degree. So this column just wants you to say how many degrees is it. And this column just tell me the name based on degrees. So you'll just put linear, quadratic, cubic, quartic, whatever. That's all it wants, okay? Look at this one. This example will need to be simplified. So get rid of the parentheses, combine like terms before you tell me how many degrees it is. Simplify it first, okay? Something might cancel out. Part 3, on this one, you classify the polynomials based on the number of terms. I think all of these can be simplified. So simplify before you classify. Once you simplify, it just wants to tell how many terms and the name based on how many terms. Okay, it doesn't want both names, just the name based on terms. You got to simplify it first. And then number 4, it gives you these 3 functions and it wants to know you circle either closed or not closed, and then addition, division, multiplication, subtraction, whatever. Okay? So now you can tear this out of that practice book. It's page 110. You're not to have your phone out until this is completed and turned in. Please make sure your name is on the top, your name, first period, and I will come around and collect your books. Everybody at home, again, if you're at home on quarantine, you won't be here for a while, I would definitely download and print off the workbook pages. They're on Schoology on the Materials tab, Module 5. And then I also posted, I scanned this page, the homework page, and it's on there too. And we'll see you when you get back.